Industry is the backbone to the wealth of society. Industry takes the creativity of scientists and transforms it into useful objects, jobs and wealth. In this cycle, research is the food for industry, providing the energy and substance. Without these innovations and discoveries, we would still be hunter-gatherers. But instead, we live in a society surrounded by electronic marvels, integrated transport networks, abundant food, and a lot of free time to enjoy the things we like. The Euratom Fusion programme is a good example of European-wide integrated research, steeped in innovation and challenging the frontiers of technology. Fusion research is typical of a big science programme. It has clear objectives and a diversity of technologies that stretch the manufacturing abilities of industry. Challenging existing knowledge is the route to innovation, and in the Fusion programme, this is happening every day. Like all large engineering endeavours, a fusion reactor requires a wide range of technologies, from cryogenically cooled superconducting magnets to high-temperature heat transfer systems. This therefore requires a broad spectrum of industry to help design and build components. Industry cannot do this alone. They need to act in partnership with the scientists and engineers who have defined the problems and together find the solutions. Currently in the Fusion programme, there are several ongoing projects. The Jet Tokamak in Culham, Oxfordshire, Great Britain, is being upgraded to improve its performance and provide valuable information to the next major fusion experiment called ITER. An alternative to the Jet Tokamak design is the Stellarator. One called Wendelstein 7X is under construction in Greifswald, Germany. A smaller tokamak compass has been moved from Culham to Prague in the Czech Republic with significant upgrades. There is also a state-of-the-art high-power linear plasma generator called Magnum PSI being built in the Netherlands. These projects alone represent an investment of more than €400 million in technology development. To provide these test facilities, industry has worked hand-in-hand with fusion researchers. With the ITER project, there will be even more scope for innovations and their exploitation. This close collaboration between industry and research brings many benefits to both sides. The researchers gain the know-how of manufacturing and are able to produce more practical and cost-effective designs, but industry has many more opportunities. They are often asked to create new techniques or develop new products which can be exploited outside of their usual business model. One such example is company MAN DWE, who won the contract to supply the vacuum vessel and cryostat for the W7X project. To fabricate this complicated component from 20mm thick steel required the company to explore new manufacturing methods. On top of this, tight engineering tolerances made it necessary to use advanced metrology systems. In addition to providing positions for engineering graduates, the knowledge gained from these contracts put the company in a position to win the contract for the 200-ton Kathrin vacuum vessel in Karlsruhe, Germany. In the words of Dr. Franz Küffner, the head of instrument engineering at MAN DWE, mutual technological benefit, affording powerful advantages to both IPP as client and particularly MAN DWE as supplier, have come from this project. In addition to this, other developments led to patents that in the near future will lead to licenses and further diversification for the company portfolio. Refurbishment of existing equipment has also brought industrial benefits. The Compass experiment in UKAEA Culham, with the support of Euratom, has been relocated in IPP-CR in Prague. The project took 2 years to accomplish and has brought greater possibilities to Czech researchers, but it has also provided benefits to Czech industry. IPP-CR and company CKD Nova Energo worked closely together to design and provide the high-power flywheel generators. The specification for these was above the normal CKD product line and has thus expanded the horizons of the company. As emphasised by Ulrich Mikus, Technical Director of the Department Developing Turbo Machinery and Power Generating Equipment of CKD, CKD delivery reflects combined effort of our R&D and extended cooperation with local universities as a unique opportunity to steer global energy solutions to the brains of our younger generation in provincial areas of Czech Republic. This project increased the pool of talented newcomers for IPP and our CKD R&D department. Robotics are another important area in fusion research. Remote maintenance is required in many fields such as space, nuclear power, mining, etc. In Finland, Euratom techers have developed various robotic solutions, including a sophisticated welding robot and hybrid welding systems. At present, this technology has not been exported to non-fusion sectors, but it is a good example of fusion research providing advanced welding and robotic processes that could improve the competitiveness of EU heavy fabrication industry. As you have seen, there is great scope for the exploitation of innovation generated in public research. The European Commission, through Euratom, offers industry the opportunity to capitalise on the innovations that it generates.